My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 630. In this lecture, I will continue my discussion on transfer learning. Before understanding this lecture, I will recall my previous lecture, that is lecture number 629. Imagine if capital D, my data set, is medium sized and D is very similar to my ImageNet data set. Let's think of this as case 3. If this is the case, then I can just choose to fine tune the last few layers, isn't it? I can choose to fine tune the last few layers. The last few layers, that's important. If the original data set is large, I can fine tune the complete neural networks. I already discussed this one. Just try to recall. If the original data set is large, I can fine tune the complete neural networks because I have lots of data. And imagine I also have extremely powerful GPUs. If you don't have GPUs, processing large amount of data is hard. So if you have medium sized data, you might want to fine tune last few layer. Okay, let's go to a different case. What is this different case? Let's go to a different case now. What if your data set is small and my data set is not same as ImageNet data set? Let me assume this is the case. Data set is small and data set is small and my data set is not same as ImageNet data set. Then what do you do? Very simple. You have your VGG architecture, isn't it? You have your VGG architecture with multiple layers. Let's assume you have a dense layer. Just you can check dense layer here in your VGG architecture. This is dense layer. The C1, C2, C3, C4, these are known as convolution layer. C1, C2, C3, all these are convolutional layer. Remember, this is very important. Your data set is, what is this? C1, C2, C3, C4 are convolution layer. Here which one is important? Data set is small and also data set is very dissimilar from ImageNet. What would be doing now? Here we will take all the outputs. Here what will you do? Here you will take all the outputs at the earlier layer, isn't it? If my D is same as ImageNet, I am taking the last layer, isn't it? Last layer data as feature engineering step. Yes, I will let me repeat this one. What we are doing here we will take all the outputs at the earlier layer. That is important. Here you are taking the output at the earlier layer, isn't it? If my D is same as ImageNet, I am taking the last layer data as the feature engineering step. But if D is dissimilar, and another one is not same dissimilar, it is not same as my ImageNet data. But still imagine if I have image data set. Still imagine if I have image data set, edge detection, shape detection are still useful. That's what it says. Edge detection and shape, just this one, edge detection is useful, shape detection is useful. Why? Because I am assuming it's an image data. As I will repeat, if I have image data set, edge detection and shape detection are still useful. So I will take the output that I get here and I will simply flatten. Just see what I am doing here. Just I'm taking the output at earlier layers. That's important, isn't it? I'm taking the output earlier layer, means after C1, C2, C1 is useful edge detection, let me assume C2 is useful for shape detection. So I will take the output that I get after C2, and I will simply flatten, and I will use this as features. This is other hack. This is especially very useful when your data set is dissimilar to the original data set on which the model was trained, and your data set is small. Since your data set is small, you can't train. That is important. Since your data set is small, you can't train a full-fledged network, isn't it? You can't train a full-fledged network. What do? You will leverage the network partially, because this layer might do first layer might do edge detection. Just see, first layer might do edge detection, the second convolution layer may do shape detection, isn't it? Why throw it out? Throw it out? Take one of the earlier layers, the output here, and flatten it. That's why I'm taking output here, I'm flattening it. Just say flatten it and use it as feature engineering. You just dump everything else here. Means you can just dump everything else from C3 to till dense layer. So use the initial layers as your feature. Use the initial layers. This is important. This is very, very important. What it says. So use the initial layers as your feature engineering to create again some CNN like codes, isn't it? This is just like it is just like CNN like codes. But one thing one must understand, actually what it says, of course, this CNN codes are very different from the CNN codes when you have all of the layers. I will repeat, of course, this CNN codes are very different from the CNN codes when you have all of the layers. There is a case 5, isn't it? There is a I can say fifth case, which is your data set is large. Let me assume data set is large and it is different from ImageNet. That's also important, isn't it? Initialize the model using VGG16. Initialize the model using VGG16 plus ImageNet features. Even the data set is not same. Using them as an initializer certainly helps, because this model is well trained. The whole VGG model is well trained. You just fine tune the whole network, because your data set is large, isn't it? Because your data set is large. All these are, I can say, all these are multiple cases, very, very important. Actually, there is a very nice blog. I would like to show you that blog. I request all of you to go through this blog. Certainly this blog is useful. Just show me this blog. Just see. CS231N convolution neural network for visual recognition. Actually, he is explaining what is this one, what is transfer learning, coordinates as fixed. Just I request you to go through this particular blog. They explained all these things very nicely, so that you will get real intuition of what we are doing, isn't it? Actually, a nice blog written for CS231N course that is started at Stanford, and this blog explained all of these cases with lots of details. What I have shown with lots of details, what I have shown here is basically inspired by this blog, isn't it? I will provide reference link to this blog in the description section of this video. Just go through it. If you have any difficulty, please keep a comment. Thank you very much.